In this video we'll run through the three further examples on the free radical substitution mechanism. The first one here is between ethane and bromine, the initiation stage. Remember, with UV light, rather than chlorine, this time we've got bromine, and the bromine molecule will split into two bromine radicals. Remember, there are two propagation stages. In the first propagation stage, our bromine radical is going to look for an electron. Who's it going to get the electron from? Well, that's going to be the ethane molecule. So one of our bromine radicals attacks the ethane molecule. Where does it get the electron from? Well, it's going to rip a hydrogen atom from the ethane molecule, and that will leave behind C2H5, and this will have an unpaired electron. The unpaired electron being on the carbon, or one of the carbons, as well as producing hydrogen bromide. In the second propagation step, our ethyl radical will want its electron back. It can get it from a bromine radical, but that would be a termination step. So instead, it will take it from a bromine molecule. This will produce our bromoethane, and the other product being a bromine radical. There are three possible termination steps here. Let's have a look at the radicals that we've got. So we have ethyl radicals as well as bromine radicals. If two bromine radicals combine, this will give us a bromine molecule. If an ethyl radical combines with a bromine radical, we'll make bromoethane. And if two ethyl radicals combine, as we can show here, thank you, hopefully we can see that's going to make butane. This next mechanism will show the steps to add a further chlorine atom to something which has already been halogenated. The initiation stage we're quite used to now, so this is just the breaking of the bond, making two chlorine radicals. In the first of the propagation steps, our dichloromethane is attacked by a chlorine radical. Remember, the chlorine radical wants to take an electron from this molecule, and the easiest way it can do it is to drag a hydrogen along with its electron away. So we just have one hydrogen remaining on the carbon now, and the two chlorines. This has produced a radical in addition to our hydrogen chloride. In the second propagation stage, we want to add a chlorine onto this radical, and we do it using a chlorine molecule so that it's a propagation step, and we'll continue. So we now have a third chlorine attached to the carbon, so we've now made trichloromethane, as well as producing a chlorine radical which will go on and react further. For our termination steps, let's have a look at the radicals that we're dealing with. So we have the chlorine radical as well as the CHCl2 radical. So the possible combinations, the easiest one being just two chlorine radicals recombining to form a chlorine molecule, or it might have been the CHCl2 radical combining with a chlorine radical to make trichloromethane, or it might have been two of the CHCl2 radicals which would happen like so. making this molecule. See if you can name it. Well done if you're able to get 1,1,2,2 tetrachloroethane. The final example looks at the reaction between propane and chlorine to form 2-chloropropane. Of course, when these two things react, you'll also get 1-chloropropane as an isomer. So the overall reaction, I'm just going to draw skeletally. So there's my propane as well as chlorine, and here's my 2-chloropropane, the other product being HCl. The initiation stage we're very used to now, producing chlorine radicals. For the first propagation stage, let's have a look at the propane molecule that we're going to attack, and we've got a choice of hydrogens that we could remove. So I could remove a hydrogen from the end of the molecule, but this would ultimately lead to 1-chloropropane. So instead here I want to remove a hydrogen from the central carbon, and this will give us the 2-chloropropane that we've been asked to produce. And let's show that in our balanced equation. So we'll make the central carbon the radical as well as the HCl produced. This means that in the second propagation step, we'll take that radical down, react it with a chlorine molecule to produce not 1-chloro but 2-chloropropane as well as the chlorine radical. For our possible termination steps, here are the radicals that we're dealing with. Let's have a look at the three possibilities this time. Well, the simplest is simply that 2 chlorine radicals will combine to make a chlorine molecule, or it might have been that our chlorine radical combines with the propyl radical to make 2-chloropropane. Perhaps most interestingly, 2 of the propyl radicals could combine like so to make a bond between those 2 carbons. Which perhaps we can see is 2,3-dimethyl butane. And for this final termination step, I'll just illustrate it by showing skeletals.